Hey everyone, let's talk Stackr. So imagine you're building a DEX rollup. Okay, right now you have to do like a lot of things. You have to write codes in, you have to write contracts in Solidity and whatnot. So imagine you could build your order book in JavaScript, and you can add a matching engine in Python, and you can add a third-party liquidity pool hosted by someone else, and that becomes your entire DEX rollup. Or you're building a completely on-chain game. You have to do a lot of things right now, but what if you could write the game logic directly in Unity? And you can connect a third-party NFT marketplace along with it. Or you could just write your game backend in Python, connect a third-party NFT marketplace, and just anyone can come in, write mods and front-end in whatever language that they choose. That is made possible by Stackr. And Stackr is a micro-rollup SDK for scaling Web3 applications. About me, my name is Kautuk. I'm the founder of Stackr Labs. Previously, I had been working with the Ethereum Foundation on Hubble and BLS Wallet, and I have also helped LifeWare move the protocol. App-specific rollups today are VM-based, and hence they're heavy. They have limited customization, and they kind of suffer the same design flaws as any other EVM role. So it should be actually considered an anti-pattern to run a full VM on top of another VM, because that doesn't unlock the full rollup potential. So what's the solution? So let's talk about custom rollup logic, and let's talk about Hubble, which was an ERC20 transfer rollup that we built. It's also used by WorldCoin at their initial infrastructure. It actually boasts of a 30x improvement over the leading L2, which is Arbitrum at that point. The data is quite old, but like that's the comparison that still holds true. So how Hubble achieved that? So it doesn't have a VM. The entire execution is in JavaScript. It has a custom state machine, which is a Merkle tree that is the entire rollup. Transactions are highly compressible because it uses a custom transaction format. It uses BLS instead of normal ECDSA, and most importantly, it is sufficiently decentralized. What it means that it has a centralized execution environment with censorship resistance, and therefore does not even have an L2 fees. How about we extend that logic to other stuff? So enter micro-rollups, which are custom state machines for rolling up any arbitrary logic. How it's possible? Because there is no VM involved, and hence the name micro. So your application doesn't run on an L2, it's actually an L2. You can build any supercharged application in between with Stackr. So you can build token transfer, you can do an entire NFT drop as a rollup, or you can just go ahead and build a full EVM. I'm not saying you should do that, but you can do that. Micro-rollups are easy to develop. They are extremely efficient. They have lower and isolated transaction fees, and their security is inherent from L1, so there is no concerns over there. So you get the modular SDK that allows building any custom state machine in whatever general-purpose language that you choose, and it also allows integration of various third-party middleware. And the next part is the aggregator network. So think of it as bundlers for 4337, but it actually rolls up roll-up transaction. So the shared aggregator network sits in between the L1 and the application, and it allows for async composability, and it rolls up your data. The Stackr philosophy is simple. So one logic, one micro-rollup. We are building microservices for the Web3 world, which is unheard of until now. The developer's lane looks like this. So you can build your rollup from scratch. You can import pre-built modules, or you can actually connect to a third-party rollup, which is already present in the network. True rollups are basically opinionated apps on permissionless chains. So you can have anything in between. So you can choose a custom execution environment. You can choose middleware. You can have ordering by yourself or by integrating flashbots or whatever. You can choose the settlement layer, L1, or any data availability layer as well. It unlocks a new paradigm for a lot of applications. You could build like a ride-sharing platform. You could build an entire cloud service stack on top of it. In fact, a lot of projects that you saw today could be built using Stackr. A lot of people told me it's too good to be true. So we built an experiment for that. It's called Pixelar, which is an online collaborative online canvas similar to our place, which is this monstrosity. And it's what we built, and the numbers which we were able to achieve look something like this. We use a custom transaction format, and it allows us to compress the entire transaction into like 3.5 times less number of bytes. The L2 throughput is practically infinite because it's a centralized server, and the L1 throughput, basically how many transactions we are able to confirm in a particular block, leads us to 1,640 transactions per second, and it's about 50 times more efficient than that. And that's not the best part of it, because if we hyper-optimize that, we can actually achieve 2,500 TPS, and that's about 100x saving, and that actually has BLS and just a little more compression going on using Brotli and whatnot. So it's coming soon. We are going to release a lot of stuff on experiments.stackrlabs.xyz, which is our experiments domain, and it's not live yet, but we are just writing a blog post, and we'll post it soon. This is what the Stackr timeline looks like. So the project was first conceptualized in March 2022. Then it was ETH Online Hackathon, where it gained some momentum. It kind of went viral. Then we received a small grant from Ethereum Foundation, and we kind of completed our fundraise in February 2023. Then we made our first partnership a couple of months back, and in Q4 of this year, we'll be releasing a DevNet. And I just want to end with one quote, which is, your next rollup is not a blockchain.